Now we come with the second content, which is the survivable network of their protection mechanism. In here, what we can see is a protection mechanism. What is the available protection in the SDH? So let's go through with this survivable network, which is protection. So the number one here will be survivable network introduction, and of course, number two there will be the protection type. So let's go through with this introduction first. So cause of the network failure, which is the possible causes of your network. In here, what we can see, this is some of the accident, the human error, the environmental hazard, the sabotage, and a lot of things can cause of your traffic interruption. So most of the time here, this is what we call the possible causes that you need to list down. So here, what we can see, the survivability network, of course, can restore for the traffic in the event of the failure. So that's why we need the protection in this event. So in here, the requirement of survivability of the network, including of the robust equipment, security, in terms of the design, redundancy, and also for the fast failure detection. So in here, the type of protection we have in SDH, we have three here. The first one, of course, is we call it as a line. The second, we call it as a ring. And the third one, we call it as a node. So the first one, let's go through with the line, which is we have 1 + 1 linear MS. And second one, we call it M to N linear MS. For the ring here, this is how we're going to consider as a multiplex section protection, which is MSP in the short terms. And here we have a PP, we call it as a path protection, and node, of course, they just only have SNCP. So let's go through one by one, which is 1 + 1 linear MS. So in here, linear protection. So as you can see, this is a chain topology. So chain topology, point to point, or maybe as a chain topology, switching within the two interconnected nodes, which is we have A, B, C, and D. Example, I want to send my services from A to D, which is I go through to pass through at B and also at C. So what will happen if I have a fiber cut around here? Of course, they will switch into a protection, whereby this is the normal routes whereby they go to the working, and if you have a fiber cut around here, so they will go to the protection in here. They will still going to the working as well. Now let's go through with the example of linear 1 + 1 MS. As you can see here, we have topologies such as node A and also for node B. And this is what we apply for the working. At the bottom of this, we apply as a protection. So imagine that the first one, of course, they have a concurrent sending, whereby it's like a splitter. They will split both direction, which is a working and also for the protection. And here also for B, for the reverse, which is B to A, they will go to this path as well, which is they have a working and also for the protection. So let's take a look of this example, whereby your services coming from A, whereby they will split into two, which is a concurrent sending. To transmit, of course, from A to B, they will go through to the working and also for the protection. By the way, for the working, of course, they will allow as a pass-through here because they have a switch there. And of course, for the reverse here, as you can see, it's a similar things, which is from B to A. Of course, they will go through with the working and also for the protection. As usual, in A here, they have a switching whereby it is working here. What if you have a fiber cut around here? Of course, you will go through to the protection. So let's go through here. What will happen to the protection, whereby in here, they will make it as a switch to the protection, and here as well, they will make it as a protection to the here. Now let's continue with the linear 1 + 1 MS here. As you can see here, we have a switching mode, which is 2 here. The first one, we call it as a single-ended, which is most of the time, it is referred of the unidirectional. The second one, we call it as a dual-ended, and it is referred of the bidirectional. Not only of that, so restoration mode also is available in this protection. So second one, as you can see, we have a derivative. We need to set for the WTR. WTR stands for wait to restore, which is we have available default, which is a 600 second. Here we have a non-derivative whereby they don't go to the original back. Here we have an automatic protection switch, which is the APS byte. It's not required in this single-ended and also for the dual-ended as well. Now let's go through with the linear 1 to N MS. As you can see here, we have a protection channel and also for the working channel. Kindly note that this working channel, you can apply many of working channel. So here we have a network A and also for network B. So the protection channel will be at the top here, which is in the top of network A and also for network B. We have working channel 1, 2 until N here. It depends on how many protection or how many working that you're going to apply. Most of the time, working channel you apply as many as you want. And here we have a working and also for the channel whereby you have a fiber cut around here, so the switching happen in A and even in B as well, you make it as a switch for the working and also for the protection. In here, what we can see the switching, and here they make a switch at node A and also a node B. So imagine that your services coming from here, of course, they will go through to the protection path, and of course, they will go to directly to the destination. Now let's go through with the linear M to N MS. As you can see here, this is switching mode, which is you apply for the bidirectional switching. And also for the restoration mode, of course, there's just only one, which is a revertible mode. So the next one will be the linear protection that available in here. But we can see the linear protection time, which is a linear 1 plus 1 ms, and also linear M to N, which is M here, it is refer of 1, which is a protection, and N is refer of the working channel. How many working channel that you apply, which is below than 14. So the second one here will be the protection switching criteria. So this is the alarm that you can find for the signal failure and also for the signal degrade. Most of the time, the signal failure means you have cuts of your alarm. And your here will be the signal degrade, which is your power could be reduced. In here, internally dedicated and also protection switching command and network capacity. Of course, this is the what we call for the linear, which is an option you apply for the protection. So the next one will be the ring topology. So ring topology in here will be, of course, you know, as a ring topology, we have a multiple network, and the type here will be 2, which is the MSP, and also for the PP here. So I'm start with the PP first, which is a path protection, which is a path protection will be more on the directly here. So MSP, multiplex section protection, and also we have the traffic direction, which is you can apply for unidirectional and also for the bidirectional. In here, we have a 2 fiber and also for the 4 fiber, which is the number that you apply for the fiber. Now let's go through with the 2 fiber multiplex section protection here. As you can see here, this is an example of it. So we apply for 2 fiber. So the first one, as you can see, this is the topology that we apply. We have network A and network B and also for network C. So this is how you're going to apply for the ring topology. And kindly note that this line board should be inserted in the dual slot. And of course, you apply for the line left unit board in here and also for the right line unit board as well. This one for the left you set as a west, and for the right you set as a east. So if you have a fiber card among them, so of course they will go to another routes, which is if you have a fiber card between A to B, of course they might go to the C routes. Now this is an example of 2 fiber MS SP ring. As you can see here, we apply of the ring topology. We have a network A, network B, network C, and also for network D. So in here we make as a reservation, which is a working path, which is a working channel we set as a VC4 time slot number 1 until time slot number 8, whereby they will go to this particular path, which is they will go to node A, node B, and also for the node C. By the way, for the protection, of course, you will reserve for time slot number 9 and until time slot number 16, whereby it is referred of the STM16 frame, whereby they will go to this particular path, which is network A, network D, and also network C. So if you have a fiber card, of course, they will alternative go to the protection. So here, this is how you're going to reserve of your VC4 time slot. Here we have a VC4 time slot 1 until time slot 8. We make it as a working channel. And of course, for the protection channel, you reserve for time slot number 9 until time slot number 16, whereby the completion of this, it will be the STM16. So here will be the section overhead, whereby we deal with the overheads of the frame STM16. Now let's go through with the example of 2 fiber bidirectional MSP ring. As you can see here, the normal traffic flow between network A to network C. So from here, we have a ring topology whereby the network A, B, C, and D. So in here, I want to make a normal flow, which is network A, go to the network B, and go to the network C. By the way, I will make it as a protection whereby they will go to the network A, D, and C. So let's take a look in this example whereby our services coming from A, they will pass through to the node B, and whereby from B, that's directly drop our services at C. And not only of that, of course, we need a reverse, which is node C. Of course, they will go to the node B, and node B, of course, they will make a drop at the node A. So this is an example, the normal traffic flow. So let's go through if you have a fiber card in the next part, which is in here. So as usual, we have a fiber card between A and B. In here, this is an example of it. If you have a fiber card which is both fiber has been down. So in here, in what we can see, the services, of course, they will go through to another routes whereby they will go to the D, and not only they will drop at C, they will pass through to B as well to make a switch and directly go back to the C and perform of dropping. Not only of that, as a reverse as well, they will go directly go to the B and make a switch directly go to the C as well, and here it will go to the D and drop it into a A. So this is how it looks like when making a switch of the MSP. So here what we can see, we apply for the STM16. In here, they just make it as a pass-through of these two, and here, this is a switching happen. So the next part will be a 2-fiber MSP ring. When the fiber is repaired, of course, if you set for the derivative, you need to set for the WTR, wait to restore. Most of the time, the default, it will be the 600 second. So if you set as a derivative, of course, if you already solve this problem of this fiber cut, they will automatically go to the original back. So here, for example, if you restore it, of course, they will go back to the original. So here, how it looks like, whereby they will go to here. As normal traffic, which is from C, they will go to the B, and B, of course, they will go to A. So the next part will be this kind of mechanism of this protection, whereby the APS. APS is required of this protection triggered. So here we have an alarm that involves, such as example here, which is a signal failure. This is an alarm that involves such as RLOS, RLOF, MSAIS, and the rest. For the signal degrade, of course, it is referred of the power. If your power is degraded, of course, it might be affected your services. In here, the protection switching restoration, the APS might be required. Of course, this is a clearing for the SF. Most of the time, if you apply for the derivative, you have to set for the wait to restore. For example, in here, 10 minutes, they have a duration which is 5 until 12 minutes. So the next one, it will be the 2-fiber, similar like the previous. But in here, as you can see, we have a fiber card. And of course, the APS controller will be make it in the protocol whereby they have a K1 and K2 byte. So in this SDH, of course, K1 and K2 byte, it is used for the protection byte. So here, if you have a fiber card among them, so of course, we'll set as a switch here, and this one, we make it P as a pass-through. So this is the idea of it. So if you have a fiber card among here, so of course, these two will make it as a WTR. If you set as a derivative, they will have a time for the restoration. And this two here will make it as a pass-through. So here will be the idea of the 2-fiber MSSP ring. So here the features of this MSSP ring, the advantages, of course, the time slot can be reused. Of course, the height capacity, height network capacity, which is 1/2 times with M, and also depend on what is the STM frame that you apply. In here, which is M, the number of the node in the ring, and SDH is depend on the STM level. It can be also STM1, STM4, STM16, and also STM64. The disadvantages of this will be mechanism is too complicated. Yes, this protection might be complicated to handle. And of course, for the maximum number of nodes in one ring is limited into 16. So here, the application mostly we apply for the STM4 and also for STM16. You can apply for the above of it, which is another, such as STM64, but it will be more complicated at the end. So here will be scattered traffic distribution. Previously, we go through with a 2-fiber. Now we are go through with a 4-fiber MSP. So here we have a MSP ring, which is a SP ring here. We apply for the ring topology. We have a network element A, B, C, D, E, and F. So here we apply for 4-fiber. As you can see here, the working channel, we label it as a S1 and also S2. So this is how you're going to make as a reference, whereby the P1 and also for P2, you set as a protection. So in here, what we can see, I want to send my services from A directly to D. So the pass-through, of course, I will make it as a F and E as a pass-through. So in here, what we can see, the normal services that I go through, which is from A, and of course for the reverse, of course, I will go through to the same path, which is A, F, E, and D. So in here, what I'm going to show, which is I have a fiber card among F and also in E here. So that involver of this fiber card, it will be the 2-fiber. So let's take a look in here. If you have a fiber card between F and E, so how the perform of the switches? Of course, in F and E here, the perform of the switches because they are both direction. So in F, of course, they will make it go to the protection, and here they will go switching directly go to the normal path as well, which is a working path. So here, this is a 2-fiber cards. If you have a 4-fiber cards directly, it will happen like this. Of course, your pass-through in here will be in F. They will make a switch and they will go to another direction, which is they will go to B, C, D. Not only drop at D, they will go back to E to make a switch in E here. So this is how they make a protection, which is in E here, they will make a switch, and also in F, they will make a switch as well. So this is how they perform of drop of services at D. So here this is the mechanism, which is the switching triggered condition. If you apply for the APS here, so this is a make it as a ring, and it can be also as a span. So here, signal failure, we have a fiber cuts directly, which is the alarm that involved, and signal degrade, maybe it is because of the power. And this is the external protection switches, such as a spring and RAM. You can make it as a force switch, manual switch, and also for the exercise switch. Most of the time, this is for the maintenance part. So this is the protection switching restoration. So APS in here will be make it as a ring, and it can be also as a span. So you clear off the SF will be a signal failure. This is the alarm that involved, which is the R loss, LOF, and the rest. For the clear of the SD, this is the alarm of it. And of course, for the restoration, WTR, you have to set it as a 10 minutes, 5 to 12 minute provisionable. So here, the APS control status, you can have this kind of four, which is the idle, the switching, the pass-through, and also for the WTR, wait to restore. So here will be the features of this 4-fiber MS experience. So here the advantages here, as you can see, the time slot can be reused as well, similar like the previous. And here will be the high network capacity. And here, disadvantages, the maximum number of this one rig is limited into 16 only. So here the mechanism, of course, is too complicated, and you need a lot of experience to handle this kind of equipment and also kind of protection. And of course, this protection is very, very expensive. So here the application, most of the time it is applied for the big capacity, such as STM16, which is 2.5 gig. Here will be the scattered traffic distribution, and most of the time, because you deal with a big capacity, of course it is referred of the backbone system. Now let's go through with a summary of this protection, which is the 2-fiber and also for 4-fiber MSP ring. So in here we can see we have a different and also for the similarity. So in here we have a MSP ring. So this is a 2-fiber and this is a 4-fiber. In terms of similarity, of course the APS protocol will be necessary, important here. So here will be the node of the MSP ring, which is the 16 time slot here. And this is the SEC to configure the MSP protocol for dual slot and the rest. Let's take a look for the difference. So for the difference, for 2-fiber, of course, they need to multiple with the half of it, which is the M times with the STM, and divide it into 2 capacity. So without the extra traffic as well. So in here for the 4-fiber, so you need to multiple. They don't divide it into 2 of the STM frame. So here, similar like a without extra traffic, and it's very unique span switch, and of course they involve of the bytes such as K1 and K2 bytes in the 4MSSP ring. Now let's go through with another protection, we call it as a path protection. So this is a 2-fiber unidirectional path protection, whereby we apply for the diversely routed PP rings. As you can see here, we apply for the ring topology, similar like a previous. But this one, as you can see, if you have a fiber cut directly, they don't go to the other nodes, which is the perform of the switching, which is this one, they will perform directly, go to the nodes directly here. As you can see, we have a fiber cut, for example, this is node A and this is node C, whereby I go to this particular path. If you have a fiber cut around here, of course, they will go to this particular path, which is they will go to D. But they don't pass through to B anymore, whereby to perform of the switching. They will make it a switch directly in C, whereby if we have a fiber cut around here, so they will go to D and directly drop the services at C. So this is how we apply for the PP protection. So here, this is an example of it. Just now I mentioned, if you have a fiber cut around here, of course, both cannot go to this direction anymore. Of course, here they will go to this direction and they will make a switch directly in C. For the reverse as well, it's the same thing. Of course, they will go to the D, and in A here, they will perform of the switching. So here will be the diversely routed PP ring. As you can see, the protection switching trigger condition. This is the alarm that involved for the switching, such as the tributary, AIS, and the rest. So the features here, of course, we will refer to the every path, which is the 2M here, which is switches independently, and restoration mode you can set as a derivative. Of course, derivative we need a WTR. Now let's go through with another protection type. We call it as a node protection. Here we call it as a SNCP, sub-network connection protection. In here, the protection features, as you can see, we have 3 points here. The first one is similar like a linear. We have a concurrent sending at the transmit side and selective switch at the receive side. In here, 2-fiber unidirectional traffic will be required, and also 1+1 single-ended protection. Here, this is the protection switching criteria. We have 3 here. The first one, of course, you can set for the signal failure, SF, and second will be signal degrade in terms of the power, and the third one will be the internally indicated command. So here will be the example of the sub-network connection protection, whereby we have a particular node which is network element A and network element E. So not only of that, they will go through to the another sub-network 1 and also sub-network 2. So sub-network 1 we set as a working SNC, and also for the protection we've set as a sub-network 2, we make it as a pass-through. Inside of this sub-network 1, of course, they will have a multiple of the topology, and sub-network 2 also they will have a multiple of topology inside. So this is a two direction different. So here we'll be working, and of course this is for the protection. So of course if you have a fiber card in here, of course they will go directly to the protection. So this is an example of SNCP. As you can see here, the traffic, transmit, and also for the receive condition. So here, whereby I will go through to B here as a working, and for the D here as a protection. I repeat again, so this one will be more on the working, which is A, B, and C is a working, and A, D, and C is the refer of the protection. So whereby we apply as a SNCP ring. So here what will happen if you have a fiber cards around here, which is your services cannot go through to this B anymore. Of course, they will go through to the D here directly in C. In C here, they will make a switching for the direction A, D, and C. Not only of that, from C, D to A, of course, the switching always happen in here. So here will be the protection speaker condition. As you can see, the default, we set it at, this is the alarm that involve it. For example, such as AUAIS, AULOP, and the rest. The optional, it will be this kind of alarm. So the next part will be the SNCP, which is the protection restoration. You can set for the restoration, which is you need to set for derivative. We need to set for the WTR, wait to restore. So most of the time, it is referred of the 10 minutes. Actually, you can set as a 5 to 12 minutes provisionable. So here, if you have a fiber card in here, of course, the switching will happen in here. So 10 minutes later, if you already solve this kind of alarm, which is a fiber card around here, so probably they will go directly to the normal path. Now let's go through this summary, which is at the end of this topic. So of course, survivability is very important because you might have saved your traffic. Of course, protection is very important. Of course, here we can make a very good of the survivability of your network. So number one here, as you can see, we need to make a survivability of the network, which is restoration services in a short time. And of course, without any human intervention in the event of the failure. So the second one, of course, we need to know what is the protection we already know. Here, the first one will be the linear protection, which is linear 1 plus 1 ms. Not only of that, linear m to n ms as well is very important. So the third one, it will be the ring protection. There are two things here. The first one, it will be the MSP protection. So the second one, we call it as a PP protection. And last but not least, we already know, which is the SNCP, sub-network connection protection, which is applied for the different of the network. Thanks for watching.